Good morning. Hello, hello, hello. Um, welcome. My name's Joe. I work at the Buck Institute with Dr. Yurkovich here. Uh, Dr. Yurkovich is visiting us from Dallas, Texas, and he will be presenting on the data that we use for a few of our different studies and talking about, what the Buck does, what we are hoping to do. Um, and it's very exciting to have you all here. So thank you so much for giving us your time. I'll talk a little bit more at the end about how you guys can participate in our research and really work with us. Uh, so if um, you have any questions, please write them down on your cards and we'll be happy to answer them. Um,
Good morning, everyone. My name is Kaushik. It's my pleasure to be the CEO here at Vivalon. I'm in month number 5 and having a blast. So thank you all for taking the time to come here this morning for this really special conversation. And really, we are creating such a special relationship with the Buck Institute, and we're really happy about that and proud of that. By coincidence, I was listening to a podcast last night, and the guest was, I don't know if you're familiar with him. His name is Mike Krzyzewski, Coach K. He was the coach for over 40 years at Duke University's basketball program, which is considered the preeminent college basketball program. And he was saying that if you look at any organization that has sustained success, it is always values based and it's based on values. And I think we're in year 26 as Buck, if I'm not mistaken. I think it was 99, right? And so you can see a great example of that in terms of the values that Buck was founded on and what they continue as they get near 3 decades. So I'm hoping you're familiar with the Buck Institute. If you're not, just very briefly, their success is ultimately going to change healthcare and has been. Their research on aging is really focused on ending the threat of age-related diseases. And in short, I think Buck wants to help people live better, longer. And I want to introduce our speaker today. We're very fortunate to have him here. Dr. James Yurkovich holds his BS in electrical engineering from University of Notre Dame. And he also earned his PhD in bioinformatics and system biology from UC San Diego. And during his career in biotech, he worked in systems biology, focusing on understanding the healthy functioning of the human musculoskeletal system. At Phenome Health, Dr. Yurkovich spearheads new opportunities, technologies, computational methods, and collaborations, really the ones that bridge the gap between biology and technology. And he has an interdisciplinary background that spans mechanistic modeling, machine learning, network analysis, and dynamical systems theory. None of that makes too much sense to me. Maybe it makes some sense to you. I know it does to Larry, but clearly we're very excited to have him. Before I turn the mic over to him, I have to put a plug in. This is going to be a great symposium this morning. If you're hungry afterwards and you've never been to the Vivalon Cafe, it's just across this floor. We would highly encourage you to have a lunch. I think it's one of my favorite places in the world. You get to see so much of community and what it means to be kind and compassionate in a world that is desperately seeking for more kindness and compassion. So with that being said, please help me welcome Dr. Yurkovich.
Thank you very much. All right, can everybody hear me okay? All right, well, thank you very much for the kind introduction. I am James. You don't need to call me Dr. Yurkovich, that's fine. Like Joe mentioned, I actually live in Dallas. I'm very fortunate to come and work at the Buck. I'm out here about a week a month, running a small research lab. I have Emma from my lab is here with us today. This is the Buck, so up in Novato, right off the 101 on the west side. I love coming out to California. I miss being in San Diego, but I love coming out to California and spending time at the Buck. It's really great. I was going to do this intro about myself, but I think you just heard everything. So yeah, background in a lot of different things. After I finished up my formal education, I spent a little bit of time in pharma, where I worked for a pharmaceutical company down in San Diego. We were working on musculoskeletal drugs, looking at like knee osteoarthritis and these kinds of mechanisms. And so it was a very natural transition when I got introduced to the Buck Institute a few years ago and officially joined the faculty last year. I wear a couple different hats. I am also on the faculty at the University of Texas at Dallas, where I teach a course on digital health. There's a very new and growing area. I'm only wearing one wearable today, but sometimes you see me and I'll have like 5 or 6 rings and a wristwatch and all this kind of stuff. And so I teach a course that I designed in digital health where we buy the students Aura rings, these nice little pieces of tech that track sleep and heart rate, activity, these kinds of things. And so we buy the students Aura rings, and then I teach them about machine learning and AI and data analysis using the data that they collect on themselves. Because I think that's a way cooler experience for the kids than me just kind of giving them data or fake data or whatever it is. So we're really trying to engage the students, and we're actually in the process, we're trying to build kind of a distance ed version of that course. So maybe stay tuned. UT Dallas is doing some cool stuff. And like I said, joined the Buck officially a couple years ago, and then on the faculty for the last year or so. And who better to let
the Buck Institute is interested in understanding aging, not only to make us live longer, but to actually alleviate and suppress the development of diseases.
Chronic disease is the great health challenge of our time. Aging is the main driver of chronic disease. To eliminate chronic disease, we must harness the biology of aging so we can live healthy longer. The Buck Institute is the world's first research organization dedicated solely to the biology of aging. We work with the building blocks of biology to understand how we age.
The Buck is concentrating on really trying to go to the root of the problem, so understanding that we can sort of intervene really early.
The Buck Institute is probably the best place in the world to be working on aging because there's so many different aspects of aging that are being studied. It's key because no one lab can do it all.
Our scientific explorers are brilliant, curious, and committed.
The idea that you could actually develop drugs that slow down the aging process was really something that 20 or 30 years ago people thought this cannot be done. Not only can it be done, but we will do it.
The pieces are in place. And we are in a unique position to put them together. Our world is defined by paradigm shifts, created by scientific discoveries. The biology of aging is the next frontier.
What we've discovered is that the mechanisms of aging themselves are intimately related to the mechanisms of human disease. If we can eradicate the aging component to disease, we're all going to live healthier and longer.
It's just an incredible vision that really will, surpass anything else that we've ever seen before.
We are inviting you to a future of aging without illness. It's happening today, and it's happening here. Join us.
All right. Very quick disclaimer at the beginning. One of the reasons I introduced myself as James is because I am not a medical doctor. The stuff I talk about is for education and on research. So please just know that none of this is medical advice as we get going and talk about some of the new and exciting things that we're doing on the research front. A little bit about the Buck in terms of kind of what the Institute is, how we get our funding. Our mission is to end the threat of age-related disease for this generation and for future generations. We have about 230 employees, and we have frequently groups of interns, high school kids, college kids come in. and work with various labs. You heard from some of the other faculty in the video. A lot of our funding comes from the federal government. We write grants, as you can see down here in the bottom corner, government grants, but we also get a lot of money from philanthropy, different foundations. The Buck Trust supplies a little bit of funding, as well as business development. And there are certain different companies, biotech companies, pharmaceutical companies, that will also fund research projects going on at the Buck. So what exactly does the Buck do? So most of the Institute focuses on basic research. On the spectrum of research, there's really basic research on one side, what we call translational science in the middle, and then clinical research is the other end of the spectrum. Buck lives more on the basic research and translational research side. So this is studying model organisms like fruit flies, mice. In the aging community, the naked mole rat happens to be a very good model of aging and disease. So we studied the naked mole rat. And then whatever we learn from studying all of these different organisms, we can then translate eventually into technologies that are applicable to humans. And so the translational piece, that kind of middle piece of this, is looking at developing drug compounds, seeing if we can find biomarkers that are indicative of health systems that we can track, and then eventually moving into more clinical research. And over the last several years, the Buck has made a really big push with all of the different faculty labs that are represented to focus more on that translational and clinical aspect of this. The Buck is one of the world leading institutions for the basic science research of aging. But the focus now is how do we take everything we've been learning for the last 20, 25 years and actually make a difference in people's lives. And so a lot of the newer faculty, including myself, really focus on more of that translational piece where we're moving things forward. And overall, all of those faculty, the different labs, and all of the different research areas that I just talked about at the Buck, the one unifying theme in all of our research is that we study aging. We ultimately think of aging as the combination of accumulation of damage and the loss of regulation. So one of the metaphors that we like to think about is if I gave you a car when you're a teenager and I told you this is the only car you're ever going to have, it's the only car you're going to own for the rest of your life, I would imagine you guys are going to take pretty good care of it. You're going to take it, get it serviced every year, change the oil, do all that kind of stuff. We only get one body, and we have to think about that and take care of ourselves throughout our life. It's an ongoing, evolving thing. What does it mean to treat our bodies well and be healthy and do a lot of that? And so that's really what a lot of the research that we're doing is trying to learn and understand is what does it mean to be healthy? What does it mean to be healthy as you age, and ultimately work together to take these two pieces that ultimately lead to the loss of function that we experience as we age, and kind of work backwards from there and try to figure out, okay, how do we actually target these mechanisms of aging? How do we reverse aging? How do we slow it down? Are there different things that we can cure? Are there other things, symptoms that we can mask? That's at the core of what the Buck Institute does. Why is it important? I don't think I have to sell this to not just this group, but any group. I think that the aging research is very prevalent now in the focus of our society and culture. But aging is the #1 risk factor for almost every major chronic disease. And that is a really powerful statement when we think about all of the research dollars that go into cancer research and diabetes research, all of these different things, osteoporosis, osteoarthritis, all of these different, they're really diseases of aging. If we live long enough, we will eventually get many of these diseases. And so that's what, at the kind of the onset of everything that we do on the research, these are some of the many applications that we can target with, one kind of commonality across all of the different things that we study. And ultimately, our goal is not to make people live forever. That's not really what we do when we talk about the biology of aging, longevity research. It's a little bit of a misnomer. Really what we think about is in our lifespan, whatever that number is, whether it's 80 or 120, we have a certain amount of our lives that we spend in good health. And then there's a certain amount of our lives at the end when we're in poor health. Maybe it's loss of ability to do kind of daily things by ourselves, like go up and down stairs, all of these kinds of things. Really, the goal of all of our research is to shrink down that time that we spend in poor health at the end of our lives and increase what we call our health span. In doing so, we will probably live a little bit longer, but more importantly than that, we'll live healthier longer. And I think that's really what everybody strives for. And so, toward that goal, we have really an untenable present. There's a lot of chronic diseases. The prevalence of a lot of these chronic diseases are sadly increasing, especially in this country. And tomorrow, when we apply a lot of our research, we hope to develop novel prevention strategies, interventions, biomarkers, diagnostics, all of these kinds of tools that will help get us to this goal of extending health span. And like I said, more recently, the Buck is really making a concerted push to move from just doing basic science and studying cells in a dish on a bench and to doing clinical trials and human studies. So we have a lot of studies happening right now at the Buck, and others, a couple of these I think are planned. And one of the things that I'm going to talk to you about today is my baby that I've been trying to get worked on for the last 8 years now, is the time study. Before I jump into that, though, I want to go on a little bit of a brief interlude. I had a conversation with a couple people when I got here about some of the new developments in AI and data science, all of this kind of stuff. We're surrounded in a world that is just overflowing with data. And I want to talk a little bit before I jump back to some of the clinical research we do. What is data? How do we think about it in healthcare? And how do I, as a researcher, think about using some of these data? So the first question I ask myself as an engineer, definitely think of myself more as an engineer than a scientist. I ask myself, what is data for? I use data to predict the future. Whether it's in my everyday life, I see things, I draw inferences, and then I model my behaviors in the next step over that. The way I look at it, if you gave me 100% of the relevant information about any one thing, I have a pretty good probability of making a correct decision, whatever that is. Maybe there's a lot of correct decisions. Maybe there's not just one. It follows then that if I have some limited amount of information about a system, I'm probably going to have worse odds of making the right decision. The challenge becomes when we don't have all of the information. Or put it a different way, what if I don't know what I don't know? What if I don't even know how much information is present or absent? I really have no idea how good of a chance I have of making a good decision. This is a concept that has been called dark data. There's some interesting books. You can go to a place like Barnes & Noble and buy and read about it. But this concept of dark data, to me, as somebody who operates a research lab in the biomedicine space, this is something that really captures my mind. How do we think about modeling biology? How do we think about drug discovery? How do I think about developing new diagnostics if I don't know what I don't know about the human body? So, fast forward to how do we actually use data today? That was a little philosophical. Let's kind of bring this down a little bit. If my goal is to assess cardiovascular risk, you might go to your doctor, and your doctor is kind of following what we call a decision tree in computer science, looks at one feature and says, okay, if you're under 35, then I'm going to go down this path. And if you're over 35, I'm going to look at, this way. And if you're under 35 and your BMI is under a certain number, you're low risk for cardiovascular disease. On the other hand, if you go that tree, maybe you're high risk. And then you just kind of keep moving down this tree. You say, okay, well, does this person smoke? Yes, no, that kind of assigns risk. What kills me about this, and this really is how healthcare works for the most part, this isn't very data-driven to me. When I do data for a living, this makes zero sense to me. Especially when we think about how much data is actually captured. So when you guys go to the doctor and you get a blood test, you get back a piece of paper, or maybe you get an email nowadays. And what's measured is on the order of dozens of data points. My last blood test, I think I got 34 things back. It's things like complete blood count. They run a cardiometabolic panel. They looked at some lipids. On the research side of things, I mean, we analyze in our data tens of thousands of data points at every sample we look at. And for me, that's what the future of healthcare looks like, is the technology is already there to measure these things. And measuring, like I said, tens of thousands of things. We can look at all of the different proteins in the blood. We can look at all of the metabolites in the blood. Metabolites are small molecules that are involved in energy metabolism. So glucose is a metabolite. Lactic acid is a metabolite. We can look at way more than just 4 lipids, try like 400. And then we have a lot of digital health technologies that can help bridge the gap between these blood samples, where maybe you go to the doctor every year, maybe you're young and invincible like me and you go every like 5 years. But wearing wearables, that helps capture extra data that can help fill the gaps between when I do have those touch points with my doctor, my PCP, my medical care. And then we have a lot of things that are kind of more on the research side that aren't really being utilized in healthcare, like microbiome samples. Probably read or hear a lot about the gut microbiome, and we can profile all of the bacteria that live in your gut, help break down food, but can also cause disease and drive other health outcomes. And your whole genome sequence, generally things that are not used in medical practice today. And so what I imagine this looks like is repeated sampling of all of these things, where we gather all of these data and then we use them to make decisions. We've done this in a research setting. So this is an anecdotal case study. It was a single person who was enrolled in a commercial wellness program that we ran for about 5 years. And in this commercial wellness program, participants interacted with a health coach. And one of the participants, she reported to her coach that she had been diagnosed with stage 4 pancreatic cancer. Now, on the research team, there's really nothing we can do about that except learn from everything that we had been observing. And it turns out that this particular woman had had 4 time points leading up to this diagnosis. So we were able to look back, in history of all of the data that we had collected, and we were able to see over the trajectory of 13 months out, leading up to her cancer diagnosis. What we basically saw was that her biological networks changed. And remember, at the top of this presentation, I had a slide that talked about loss of regulation leads to loss of function. Basically, a lot of our biology works by having these really intricate and complex systems of regulation. Glucose, insulin, those are part of a regulation system, and that helps us break down food so that we can fuel our bodies. What we saw is that these systems, various biological systems, got dysregulated over time. Now, this was totally retrospective. This was not something we did and we were able to do anything. But this gives me hope, because this is absolutely something we could do in the future. If we had these kinds of data and we measured all of the tens of thousands of things, and somebody came in and we started to see, some of your network is getting dysregulated, we might be able to intervene like 11 months sooner. Absolutely. If we have the data, absolutely. And that's part of what I think is the biggest push for medicine today is very siloed. Our healthcare is very siloed. I'm young. I was in school for lots of years. My medical record, I don't even know where my medical record is, because I've lived in 5 states over the last 10 years, right? And I visited the doctor in a couple of them. I broke my wrist playing basketball in grad school. If I wanted to go back and look at my data from 10 years ago, I don't even know where I would look. But that's part of what we need to build moving forward, is the infrastructure to support all of that, so we can do exactly that. And the crucial part is, we love it for research, but it needs to become a part of medical care. If we can, just like you put money in a bank, we can take a blood sample from you and stick it in what we call a biobank, and then we can analyze that sample later. That's hugely valuable for us in research because of this kind of case study, but imagine if everybody in this room had biobanked blood samples from 10 years ago, 30 years ago. We would be able to do a side-by-side comparison, and instead of comparing you to a population average of everybody else in this room, you're comparing you to yourself. That would give us just so much information and data that we can use to move forward and make good decisions. And one of the other things that is more on the cutting edge of what we're doing right now with all of these data is attempting to derive wellness metrics. So you go into the doctor right now, and they measure your height and your weight, and then they calculate your BMI from this. A stunning number of clinical decisions are made based on your BMI. But that's not really an accurate snapshot of your molecular health. In fact, it doesn't account for that at all. And so one of the things that Noah Rappaport led, who's another researcher at the Buck Institute, another faculty, she led a research study where she developed an integrated health metric that used a lot of these data points that we capture to derive a weighted BMI that gives you more of an instantaneous snapshot of what is your metabolic health that's actually reflective of your biology as opposed to just height and weight. And it's here where I always like to jump in and ask the question, is more data always better? So I threw this chart up here, but I intentionally didn't label it. This is the interactive part. What do we think this chart represents? Pardon? Bias? Any other takers? Data collected, we're getting really close. This chart represents the world's human genome sequences. Now, it's really hard to kind of categorize who's been sequenced and looking at all the data, but the most recent data I could find from a few years ago now, I can tell you the world is not 78% white, but 78% of the human genome sequences that we have are from Caucasian individuals. Why do I bring this up? Why is this important? Let me give you a real world example. So there's a particular genetic variant of the gene ApoE that is a known genetic risk factor for Alzheimer's disease. Its clinical impact, however, varies pretty significantly across different populations. And failing to consider this diversity can limit the development of effective therapeutics. So that's me wearing my pharma hat for a minute. So this chart on the right that I'm about to kind of animate stuff in on, the y-axis here, how tall the bars are, that represents the risk for Alzheimer's disease. For individuals of Hispanic descent, having this very well-known risk factor actually confers very little extra risk. For Black and African individuals, there's higher risk, but not a ton. Caucasian white individuals, it's high. For individuals of Japanese descent, this particular genetic variant bestows huge risk for developing Alzheimer's disease. And so I want to highlight this and bring this plot back in. If we know that looking at genetic data can lead to different risk factors, potentially different therapeutics, different treatments, different diagnostics, it's kind of a problem that some of the most understudied groups of humans are the ones who would actually benefit the most from studying particular diseases. And so when we think about data, I would say more data, it's not always better because I really need the right kind of data. As long as I have the right kind of data, then I'm good. And I would love all of the data I could get. But garbage in, garbage out with a lot of these models. So what kind of stuff are we doing at the Buck to address everything I just talked about? Well, through the clinical research unit, which Joe helps run all of the recruitment for, that's why she's here, we address a variety of fundamental scientific questions through small, focused trials. So we generally, we're not running clinical trials in the thousands. We're recruiting small, focused cohorts. We run them, for the most part, all through the Buck. On site, we actually have at least one study that has 3 different study sites in Connecticut, Ohio, and here. We do all of the sample and data collection at the Buck. That kind of varies depending on what the study is and what it's targeting. We generate all of the data from samples. A lot of that is done at Buck. Some of that we outsource to different vendors. And then people like Emma jump in and do all of the next-gen analytics and really learn cool stuff from all the data and derive new insights and new mechanisms that we can target. So I mentioned earlier that I'm an engineer. So my goal in running studies is to, like I said, get the right kind of data. But at the end of the day, my goal as a researcher is to develop effective therapeutics. Now, a therapy, I just want to say, a therapy doesn't necessarily mean a drug. An effective therapeutic could be a nutrition plan. That could be some sort of exercise plan. I'm not just talking about pharmaceutical interventions here. In order to develop effective therapeutics, I need to be able to track the system. In the business world, we call these key performance indicators, KPIs. I need to have some sort of metric that I can track so that I know whether I improved the system or not. Because otherwise, thinking drugs, because that's an easy example, I don't want to give you a drug if I can't tell if it's doing anything. We have to have something that we can track. And in order to develop robust metrics, we have to be able to reliably measure the system. Now, why do I say all of that? Here's the staff for the Buck CRU. John and Brianna run and operate. This is kind of an old slide. There's not a lot of you on here. Yeah. The team has exploded. Yeah, there's a lot more of them now, and Joe's not even on here. One of the challenges that I've seen in developing a lot of diagnostics and biomarkers is being able to reliably measure the system. So I talked earlier about looking at data that comes from blood samples, for example. And I don't know about you guys, but have you ever gone to the doctor before? I certainly have, where I go in, I get my blood tests back, and I look at it, and I see my cholesterol's a little high. I'm like, is my cholesterol really high, or did you just catch me on a bad day? Like, what happens if I went in this afternoon, or tomorrow, or next Tuesday? Is it going to be the same, or was it just me? Was it just today? The answer is that for a lot of the clinical biomarkers, the answer is yes, it will be the same. That's why they're clinical biomarkers. They've been extensively studied. But for all of the research grade technologies we use, nobody's ever looked. And so as we develop new technology, we try to measure more stuff. I talk about measuring tens of thousands of different analytes in the blood. One of the challenges we have is there might be some exceptional biomarkers in there, but we don't actually know how they behave and how they change over time. And so we are currently running the TIME study at the Buck. That's the Temporal Investigation of Multimodal Elements. I'm very proud of that acronym. Basically, the goal is to define and map the biorhythms of the human phenome. In other words, I want to understand how everything in the body changes over time. Because at the end of the day, it doesn't really mean a lot if I take a static snapshot. And to your question earlier about, what if you had samples? That's exactly what we need to actually learn about a system, is I need to watch it over time. And even better, I need to watch it over time, and then I need to perturb the system. I need to poke it and see what happens. That's really how we learn. And so we've already launched. We have 2 people enrolled right now. 3 people enrolled, my first 3 time travelers. We're out of 150. It's a pretty intensive 11-week study period, and then we'll have 6 and 12-month follow-ups. We've intentionally left the enrollment for this study pretty open. It's really over the age of 55. And when I say generally healthy, it's basically stable chronic diseases. We tried to make this as open as possible. I didn't want to just target one group of people. You just listen to me talk about getting the right kind of data. We want to make sure that we're capturing the human condition. Everything is happening at the Buck. And this was funded from a very large award of the Buck Institute, up to $52 million by the Advanced Research Projects Agency for Health, that we're extremely excited about. And Bree and Allison at the Buck are really the ones running the clinical trial. All of the ClinOps is on them. I'm just the data guy. Emma and I wait, a year until we get the data, and then we dive in and do the fun stuff. So this is kind of a complicated slide, but actually, you know what? I'm just going to skip it and go to the next one. Not that this is any less complicated, but over this 11 weeks that I mentioned, people are going to come in once weekly, and we're going to collect a lot of data. And then on 4 specific days, we're doing what we're calling our high frequency, where study participants will come in on a Thursday, Friday, Monday, Tuesday, and spend all day at the Buck, so that we can look at the kind of minute to hour to day rhythms. There's a lot of these kinds of things that we know exist, and we just haven't really studied them. And then as we expand outside of these 4 days, then we get the kind of day-to-day, week-to-week. And then we have the week-to-week, month-to-month, and the 6 and 12-month follow-ups allows us to capture really a holistic view of each person, capturing all of this data over time. We have 2 different challenges. One of them is a VO2 max test. That's a cardiopulmonary exercise test. Joe actually runs some of these at the Buck, at the clinic. Basically, you ride a stationary bike, and we measure your respiratory capacity. Your VO2 max is actually one of the few markers that is known to correlate positively with longevity. And it's something that you can actively train on. You can improve your VO2 max. I think it involves running a bunch of wind sprints. That doesn't sound fun, but you can modify your VO2 max. The other one is an oral glucose tolerance test. This is one of the gold standards for diagnosing diabetes, also very common standard of care in pregnancy, looking for gestational diabetes. This is a way for us to categorize and look at the metabolic system and metabolic health. What kinds of things do we do with these data? Well, one example is I mentioned those integrative health metrics. I talked about that weighted BMI. One of the faculty at Buck has been studying something called the circadian amplitude in model organisms, in mice and flies, and it's actually been shown to be pretty indicative of longevity for some of these organisms. And nobody has ever studied this in humans, but it's totally non-invasive. All you do is you capture a photo of your eye, of your retina. And so as part of the time study, we have a retinal scan, a retinal camera, and it takes 2 minutes. It's non-invasive. It's not even unpleasant or uncomfortable. You sit there, you capture a photo of your eye. And what we have found is that over time, and especially throughout the day, the amplitude of some of the things that we can generate from these images, they change. And that changes with decreased age. And so this is just one example of some of the analysis that we could do. We hope to be able to derive non-invasive metrics that we could use to actually give you a number, give you a score of, hey, you're aging 81 and you're on this trajectory. And if we have that measured multiple times, then you can track this, non-invasive metric and perhaps modify your behavior in order to improve this number over time. I think this is my last slide. One of the other things that we do, and these are some of my team members, of course, Emma is here today. How do we actually analyze these data? One of the things that's really, really exciting to me is all of these new AI tools, machine learning, data science tools, whatever you want to call them. We're all talking about the same stuff. We can take all of these data, integrate them together, and we can use all of these past time points to predict future time points. That's more science fiction-y. That's what I'm trying to do. And all of the data that we're generating from these studies is going to get us there, to the point where we could measure, maybe it's every 6 months, maybe it's every 2 years. If we have this longitudinal history of you, we can model that and predict, what are you going to look like 2 years from now or 6 months from now? That would actually help your doctor improve your care and give you some really good advice. So with that, I hope this has been interesting. I am actually doing the community seminar tomorrow at Buck, where I'm going to be talking about a lot of the same things, but also some different things. And I'm going to toss it over to Joe because this side is all hers.
So I know you guys are very excited about being time travelers. I want to walk you through a little bit of how you can participate, and in a way that you can also share with your friends and get them to participate. So here on the slide, we've got a QR code that would take you to an interest form. The same QR code is on our flyers outside. And essentially what would happen is once you fill out the interest form, I get your information and I will reach out to you directly via phone call or email, or both, honestly. and we would find a time to enroll you in the study so you could come visit us for the first time. Or if you come to community seminar, we can do a screening visit there and give you as much information, more information than even James gave today about each of the exact tests that we will be doing with you, what blood samples we'll be taking, what microbiome samples we'll be taking. And sort of a fun little fact is James talked a little bit about our VO2 max test. I was talking with a few individuals, and apparently in Marin County, there are a few companies that are charging somewhere in the ballpark of $300 to do that test. And we actually pay you to do the test. So I am just gonna sweeten the pot there a little. While we gather the note cards that you guys filled out with any of your questions, I will be passing around a clipboard so that you could sign up. You can put your email and your name and time in the trial category. We do also have so many other trials going on, focusing on different portions of aging. So we've got ketone studies, we've got our time study, and specifically another study called GRACE that is examining postmenopausal women specifically. That is the only population we're examining. And I really want to encourage you to reach out to your friends, colleagues, your daughters for that one. And if they do qualify, it's a great way to benefit science as a whole, but also there are always perks with us. You are compensated for every study that you participate in. So if you want to put their name and information down on that clipboard as well, I will happily reach out to them. So I'll get that started on this side. And I know we have some really curious individuals around. So I will come and grab those cards, but we could also popcorn some questions as well. Thank you. Honestly, next week. So the question was, how soon could you get into a study? Because of how many we have going and how varied they are, we absolutely could get people enrolled as early as next week. Particularly, there is a study relevant to the biobank that we are conducting at Buck, where it's one visit. We desperately need older gentlemen to be involved. So, please give us your time and we will definitely give you more information about yourselves, including a body composition assessment. So it's a very short test and it gives you far more information than just regular BMI. So it's a little, perk. We always really like doing those. Yes.
Given your previous example, you have data collected over 11 weeks, but if 2 or 3 or 8 years down the line are diagnosed with something, you can correlate the 11-week data with future diagnosis.
Yeah, great question. So we are currently funded for a 6 and a 12-month follow-up. Actually, the original funding for the study was only the 11 weeks, and we've been working hard to be able to extend it to do exactly what you're talking about. So at present, it's only 1 year, but we really are working as hard as we can. We would love to have these time travelers become a really foundational aging cohort that we can follow for 5, 10, 15 years to do exactly the kind of stuff that you're talking about. Even more so, exactly.
So one of the main questions that I think we're all wondering about is how do we keep our data and information safe at Buck? So how do we, keep things confidential, and what can we do to protect our data at home?
Sure. Yeah, this is a really important question, and it's something we have spent a lot of time on, and we've contracted with a cybersecurity firm to help monitor all of this. So first and foremost at Buck, we do not sell anybody's data. We use it for research purposes. We also believe in giving back whatever we can, returning results to the study participants. There are certain parts of these data that we are not able to return to you because it's not produced using medical grade equipment or similar kinds of research compliance. But a lot of the results, like the VO2 max test, any of the clinical labs that are done, all get returned to study participants. All of the researchers, I guess we kind of split them out into two sets. The clinical research team interact with the study participants. They're the ones that, you see their faces when you come in. They're the ones helping collect the data, all of this kind of stuff. Then we have those of us who are analyzing the data, like me and Emma, and we are never given any kind of personally identifiable information, what we call PII. So the clinical team codes all of the data, and then we only ever get anonymized data that we use for the research. So that's a very important aspect of just kind of how the clinic operates. But then on a higher level, when we start talking about and thinking about cybersecurity and data privacy, all of those kinds of things, like I mentioned, we have spent a lot of time and money and effort on making sure that we follow really good, safe practice. We actually go way beyond what HIPAA and all of the federal government requirements are. We store the data securely at Buck and on cloud servers. Only people who are authorized to have access to very specific parts of the data are granted access. And things like whole genome sequences are stored separately because there's different confidentiality and privacy concerns with different types of data. So yeah, really great question.
I'm really loving all these questions from you guys. I think touching back on AI specifically, how is AI helping us today? You mentioned different types of models we use, but if we don't know what we don't know, how is it assisting?
Yeah, that's a great question too. So when all of these large language models, we call them LLMs, think like ChatGPT or some of these other words that you hear, that's really what people mean when they say AI these days. When that all started a few years ago, one of the things that really captured my imagination is how can we use these models to help collect more data? So one of the, I talk about getting the right kind of data. One of the challenges that we face, especially when we're looking at biological data and wearable data, is when I see some anomaly in the data, is it noise in the data or is it actually meaningful signal? If I look at my Oura Ring data and you're looking at my data from today, say my heart rate spiked about an hour ago, is it because I'm standing up here and I'm really nervous giving a presentation? Is it because my boss yelled at me at work? Is it because my girlfriend broke up with me? Like what actually happened to elicit a physiological response? We were, my imagination at least, was really captured by the idea of using AI to help this. So we actually have an AI chatbot that we're implementing as part of this study. We call him Bucky. Bucky is somebody that you text with. And there's no separate app. It's just the same texting app you use to text your family and your kids and your grandkids. And through this interface, you tell Bucky about your day every day. What did you eat for lunch? You can snap a photo, send it to Bucky, and Bucky will register it. And that helps us fill in the gaps because, like I said, it's all about getting the right kind of data. And so that's a really cool way that the Buck is absolutely pioneering in this. I have not heard of anybody else doing this, using AI to help do really cool data collection, help fill the gaps.
Fantastic. Thank you so much for sharing that. Bucky is a fan favorite amongst our staff as well. There have been some questions about if you've participated in previous research, can you participate in time? And I do really want to reassure you, we love repeat participants because you have already worked with us. We know that, you'll follow the instructions we give. But it's also really fantastic because you get to learn a little bit more about yourself with each, study, whether it's observational, where, time is completely observational. We're just, watching what happens throughout your, week to week, day to day, month to month. And we'll follow up. So if you have participated before, we would love to have you back.
And let me just put a quick plug in from the research side. so helpful from the research angle, because these studies are looking at different aspects of your biology. And so one of the studies that Joe talked about, the MOVE study, is looking at the impact of exercise on healthy aging, and what kinds of exercise routines are more common with healthy agers, centenarians, all of these kinds of things. If we had anybody who was both in that study and the time study, we would really learn a lot about both all of the dynamics of that person and how exercise affects aging. And I mean, that would be, ooh, that's like Christmas for me.
Oh yeah, that Venn diagram is beautiful. We understand that there's a lot in the press right now about funding sources. James briefly talked on the funding source for the time study being ARPA-H. Could you give us a little bit more information about how stable that could be?
Sure, yeah. So ARPA-H, the Advanced Research Projects Agency for Health, is a relatively new government agency. It falls under Health and Human Services. And I think actually with a recent reorg, it actually falls under the National Institutes of Health, the NIH. A lot of what we've seen in the news is really focused on the NIH, the National Institutes of Health, and the NSF, the National Science Foundation. Those organizations, they both fund a lot of basic science research and more incremental research. This award is not actually a grant. It is an award, which we have a contract and we have milestones. And if we meet these milestones, we continue to get the funding. And the funding for this study, unlike a lot of these other grants, has already been set aside and to guarantee the lifetime of this award. But at Buck, just to kind of answer that question a little broadly, for a lot of us, that's just been an opportunity to go find funding from different places. Like I was recently awarded a similar kind of award from the Defense Advanced Research Projects Agency for Health from DARPA, which is under the Department of Defense, where we're studying similarly interesting things that can still apply to health, wellness, aging, disease, all of these kinds of things, but just going after different funding sources. So I think Buck is doing a really good job of kind of rolling with the punches and making sure that we can still support all of the awesome research that we do.
Thank you. Really appreciate that, because we see the political climate, we see everything that's going on, and we really appreciate your support by participating, but also being vocal about the research we do. So sharing and liking things on our Instagram and Facebook, and calling your senators and representatives, very, very important, and it does help Buck. There were a few questions about, where did Buck get its name, and details about Buck's history. I know our awesome Vivillon CEO gave us a little touch on that, but I do sort of want to plug in here that there are bi-weekly tours of the Buck Institute. So if you've got a little bit of time on a Tuesday or Thursday, we welcome anybody and everybody to come. We do group tours. We will actively come to your group meetings. I went to a knitting club the other week just to hang out and talk a little bit about the research that we do. So if you want to invite us over, we're happy to really come to the community. Thank you so much, James, for all of your help and sharing about what research we do. I think the last question really is why do you love your science, and what are you looking forward to coming up?
Yeah, so let me see. When I was in grad school, the first time I met my PhD advisor, he was sitting in his chair and he was leaned back in it, and he told me that grad school is all about finding that thing that makes you want to get out of bed every morning, go spend all day doing it, go to bed, and then wake up tomorrow and do the same thing over and over and over. And this is the kind of stuff that gets me out of bed every day. I'm a huge nerd. That's totally fine. I am happy to admit it. But understanding the dynamics of all of these things, figuring out how these things work, and then ultimately, like I said, I'm an engineer. I don't really think of myself as a scientist. I care about applications. I want to take all of this stuff that we're doing and actually make a difference. I want to take these technologies and develop new products and tools and diagnostics and drugs and whatever it is, to take these kinds of things and move it forward. So, I mean, what am I most excited about? I'm excited about getting some of these data and learning things that nobody has ever learned before because nobody's ever looked. And with that kind of knowledge, we're going to be armed at the Buck Institute and researchers everywhere to really do some cool stuff over the next few years and hopefully make a difference in actually translating that to all of you guys.
Fantastic. We'll take some popcorn questions here. So with the sign up form, I'll be sending you a direct email. That way you're on our sort of mailing list, and I will be including the interest form link. So both will get you there. Notably, with the interest form, it's again for all the studies. So even if you don't qualify for time for whatever reason, I will still probably reach out about different studies that we're conducting, and just keep your calendar busy. Yes. Yes. So the question was, will this presentation be available on YouTube? And it will be. Mhm. Yes. Fantastic question. For generally healthy, as long as, oh, so the question was, what is considered generally healthy?
You're asking about the inclusion criteria for the study. Yeah. Yeah. So when you follow, if you sign up, give your email, whatever, that first screening call is when they'll walk through. It is a very specific list. It's a little bit long, but the general goal is to enroll as many people as possible. Some of the other studies may have more restrictive criterion. So generally healthy, I think the major indicators would be anything that would disrupt your circadian rhythm. So like if you are a nurse and you work nights, you would be ineligible for the study. If you, over the 11 weeks, travel more than 2 time zones away, that would make you ineligible. And then there's a certain limited list of different prescription medications, mostly for chemotherapies, that would exclude you. And even that list is taken within the last, I think it's 3 years, or there's
3 months.
3 months, those kinds of, so those are the kinds of things, but that's everything that would be kind of walked through with you on a screening call.
Right, which sort of brings me back to the process of enrollment. We sign you up on the list, we send you a direct email, or it's you've been hard to track down, we'll give you a call and physically sign you up for a phone screening. That screening call lasts about 15 to 30 minutes, depending on the amount of questions or other studies you're interested in. We go through a set of 16 questions that address any medications, any health changes within the last 3 months, any travel plans, so we can, work around the holidays and, summer vacation. Perfect. Yes. Yes. So we have flyers for you to take home, as well as that describe the time study. It's this information here, as well as another study called Move. That study is, again, I feel like complementary to time, where if you are sort of slowing down, you're only working out maybe 60 minutes a week rather than 3 times a week for 60 minutes, that we welcome it. So if you're not hitting the gym as much as you'd like to, but want more information about yourself, we are enrolling for that study, and the compensation is nice. It's $275. The compensation for time is $1,250. So things to think about. Yes.
Signed up for everything that we're talking about. I've gone online.
Oh, I'm so sorry to hear that.
I don't know if I just don't qualify for
So thank you so much for addressing that. That is something I do try and reassure everybody about, is that what James didn't show in one of the slides is how our team has grown. So we went from probably 6 or 7 people on our team, and only 4 of those people doing actual, participant interaction based research, to now we're at 8 or 9. So we are a small team. And so that means enrollment for each study does take some time. And so all of that to say, you are on the list, and I do remember your name specifically because I think we've chatted before. Okay. Well, okay. Again, we go down our list alphabetically and based on our needs for each of the studies. So if you do fall into a category, I promise you, you are going to be contacted, and we send out 2 emails. It's about 6 months, a 6-month window of when you could be reached out to. We also send out bi-yearly updates on, I promise you're on our list. That's why you're receiving this email. And that email will be sent out early next week. So hopefully you'll receive that. That's a great question. Actually, we are starting a volunteer coalition through recruitment. It won't be anything specific to the actual participant interaction, but yes, I will be reaching out to Michelle about that and signups for that. So great question. There's an entire flyer outside for that. So I think we can sort of end it there. But thank you guys so much for your questions. I will be right just outside to answer any more.